Morning, guys. We'll start in a minute or two. Just seeing that everybody can join and are joining. So if you quickly want to unmute and say hi to everyone, and then we can mute again, and then we can start the session.
Morning, everyone.
Morning.
Hello.
Okay, so the recording has started, so it will be available again to the end of the session. When it's finished, it will be on the page again, and then we'll be able to share it again. So I think that is great. So the big topic that I want to cover today is chapter 5. I don't really want to. We can look at some of the assignment questions in between as well, but it's nearly, I want to take you through the thinking of chapter 2, chapter 5, because there's a lot of not just theory in there, but lots of maths that you need to get your head around to do the other things as well. So that's why I thought let's rather spend a good session on chapter 5. Then we have enough time to go through other examples, and if we get maybe a test, I've got a few exam papers that we later can go through as well that we can share. So I think let's rather just get into the chapter. Then also for the guys that maybe it's their first time on this Teams group, we have a WhatsApp group that is also running separately, but basically we're talking the same things, and we also share information in that WhatsApp group. So we do use it a lot for interaction between the students. So please, if you want to join it, give me a WhatsApp, my number, and I'll give my number at the end again. And I'm also giving it now in the chat area, but it's 083 790 8387. So you can just, after the session, send me a WhatsApp. I'll add you to the group, and there is information that we share. There's past papers that we share. So I think it's a good place also to get extra help if you're struggling. Okay, so let's get into chapter 5. So what I've hoped, just on the chat box, tell me if you can see the presentation I'm sharing. I look at the chat box on my side on another device, so if I can just get a few thumbs up if it's working. Otherwise I just need to look at if I'm still sharing it. Okay, cool. Happiness. I can see that you can see it, so that's cool. Okay, so basically what I thought, so we will go into a bit of theory, but I nearly want to start discussing what we do in differentiation, and then and you'll see a lot of this is actually what is in the study guide. So I copied most of it into the slides, but for me it's more to actually start showing you what we need to do instead of just looking at the study guide, and you need to figure it out yourself. So I think the first thing is, and I don't know if that was in this year's assignments or one of the previous year's assignment, they actually ask us to define what the slope is and how you calculate it. And I think what is important, and this was out of one of the previous chapters as well, is what is the slope? So basically, the slope is the difference, and we can look at it from, and I hope you can see where I'm pointing. So just give me a quick thumbs up if you can see where I'm pointing now at the difference in y2 minus y1. If you can see that I'm pointing, then I'm happy. Then we can. Okay, awesome. Okay, so basically we need to always work out the slope. And the slope, if you can look at this diagram at the bottom, the slope will be different for point A, for point B, for point C, however what points there are, point D. And the way you always calculate the slope is by the difference. So the difference in what your y value will be divided by the difference in what your x value will be. So if that point is a certain x and y, and that is another x and y, we will basically say the difference in y divided by the difference in x will give us the slope. And I think that is important with the differentiation, because point A, point B, that slope is different from the point B, point C slope, and it's different for the point C and point D slope. And what differentiation does, it nearly calculates a point that you want to get to. So if you want to say, I'm getting a point or a line that touches at point B, I will calculate that point. But that line will be different if it goes through A, and that line will be different if it goes through C, and it will be different if it goes through D. I think that is the first important thing with differentiation, is that you're working out a line that touches the parabola, or however you want to pronounce it, and that is basically the difference. So you can actually have 4 different points where it's a different line because it touches the parabola. The other thing that is important is, and I think we've touched on it last week as well, you get a point where that is the turning point, and that will be where we calculated the minus b over 2a. That will be one of the ones that we use to calculate the turning points. And then last week or the previous time, there was also that long formula of x is equal to, if I can remember correctly, minus b plus minus, you get the square root of something divided by 2a. That would have been, say, if a parabola were cutting the x-axis, that would have been the 2 points that we would have calculated through there. In this instance, it doesn't, and I think that is probably a positive then, that for this one, if we needed to work out certain things, there wouldn't have been x points that it would have gone through. You would only have a y-axis, or a y-axis that it would have gone through, and you would have had a turning point. Okay, so that is just basically setting the scene of how we're going to use the differentiation. So if I then go into the nearly the definition and those things, this is not, you don't need to prove anything. So we will need to see how the exam will be, and if there will be what different types of questions there will be. I don't know if I haven't heard of a communication yet, how it's going to look and how the process will work. But normally, if it was not in the lockdown period, it would have been a multiple choice questionnaire, and you basically choose answers. So it can be that they ask in the exam something like, um, what is the definition of a derivative, or what is the definition of differentiation, or something like that. If in the new environment where this is probably going to be online assessment, I don't know yet. Going to be very difficult to ask you guys some definition questions, because then you have your book available to look at it. So I don't think we will go into there. But I think what we need to do is basically, and that for me is, there's lots of work that they explain in these two slides of how to get to the point. But I just actually want to show an easy way. And I think that is always, and we'll go through a lot of the examples that's in the book as well, just to get the easy way of explaining what you need to do. Because if I look at this two slides, it's a lot of maths, and it is things that you wouldn't have seen probably before, and if you have seen it before, it would have been maybe a year or two ago. So some of it is really new things to you, and we don't need to know all of this. And I think that is the important thing. We don't need to know all of this information. Um, but I think what is important out of this is we can calculate that point that we're gonna. So if we look at that formula, the x square, the differentiation of that is basically going to be the touch point of um, that parabola. So, and the way we do it, and I'm unfortunately going to try to do it on paint again. So let's just, not this one. And I still need to get, I think somebody told me there was an easier way to work with this. So let me just firstly get this out of the way. Okay, so I wanted to get rid of that. So let's do that. Okay, so we had the x square. So that was basically the one that we needed to differentiate. So the way that we're going to do it with all of these things is, and let's add another one. We don't need to actually just look at. So let's do that, and hopefully let's just do the size a bit bigger than that. You can see much better. So the way we do this is basically we take that and you move it in front of the x. So it becomes the 2x. What happens with that one as well is you always subtract 1 from it. So that term would have become 2x. And that is also,
Sorry, sir. Sorry,
yes,
sir. We
yes.
we can't see the paint. We're only seeing the slides though.
Okay, so let's I was worried about that one. I thought everything is shared. So let's quickly thanks for that. So I need to go into it again. Okay, so hopefully I can, let's just see if I can open a new one. Okay, so, and quickly tell me, can you see now?
Yes, thank you.
Okay, awesome. Okay, so, and now I'm actually making another one up. But I think it is, for me, it's just important that we get the message of what we need to do. And I'll even, let's make it a weird one as well. Because for me, this is, and when you get it, then it becomes easy. But it is always difficult to understand suddenly what they are doing. So in the differentiation, basically the first thing we'll do, we look at the 2, we need to take that 2. If it was a 3, I'll do another one after this. We take it to the front. In this instance, there was already a 2, so it will become 2 times 2x. Then the other thing we need to do with this 2 is, because we're differentiating to the first degree, we need to take 1 away of it. So we basically go a level lower. So if you look at when we can do it here, we look at the 2, we take it in front. So here it will just be a simple 2x. The same principle applies 2 minus 1. Okay, so that's your normal circumstances where it's the x squared. This one is different. And what you need to do here is, again, it's very difficult to work with a fraction, because then it becomes very, very tricky, and you need to focus very tentatively to what you're doing. So the way that I would normally do this is to write it first in another form. So, and let's use another example. So if I had the normal 1 over 2, you could have written it as that, 2 to the power of minus 1. So the same for 1 over x, I can write it as x minus 1. Okay, so that is then the term that you're going to work with. Is everybody fine with that? Okay, so that we're not going to touch now. So what we then need to do with this one is we need to follow the same principle with this one as we did with the normal x to the. Okay, Wendy, I'll quickly repeat it again. So if you, and I'll repeat it with another example. So I think I will do another one with another example as well. So basically, what we now need to do again with that is to take it to the front. So it will be becoming minus x, or minus 1x. Remember, we take minus 1 every time. So here, now it becomes the normal minus 1 that was there, minus 1 again. And I think that is now where it becomes confusing. So this answer would have been minus 1x minus 2. Where intuitively you wanted to say, of what I would have wanted to do also, because the other ones was 2 minus 1 gives you 1. So now suddenly I am going backwards. But if you think of it in a normal number line, minus 1 gives you the minus 2. And this you will, in some instances, they would write that in the as one of your answers. But they can write it back in that form. So if you need to write it back in a fraction form, it becomes minus 1 over x squared. And I think that for me is the other way. When you look at a lot of the differentiation, sometimes they put the minus at the top, and sometimes they use it in the different formatting as well. So there's a few ways that they can actually do it. So they can have it in that format, or they can have it in that format. I am going to do another few. So it's not that, because I think this is very important. There's a lot of ways that they can ask it, and I think if you first understand how to do it, then it becomes easy. So I'm gonna open a new one that I want to. I'm gonna save that somewhere as something. Chapter 5. That was our first. And as all my other stuff, I just put it on the desktop. So let me, and we'll look at the slides again, and we'll get some other examples. But I think there's a few that, so I just actually want to do one that has and what can I think of another one? Let's quickly, and hopefully I can solve it, because you can see I'm just thinking about some random numbers. Okay, so and the nice thing with the normal differentiation like this one still, so it's still, we've got one term there, one term there, one term there, one term there. We haven't started going into, as we'll progress in the chapter, to the more difficult, the product rules, all of those rules. So this is still the simpler form of, you've got your 4 terms, so let's work with that. So out of my previous way of doing it, we take the 4 to the front. So that becomes 4x. At the top, it becomes the 4 minus 1. Okay, then this one you would have probably seen a few times in some of the questions as well. So let's just rewrite that as a different way. So that is exactly the same as to say x to the power of a half. And I think that is, so if, and sorry, just want to show another one. If it is something like that, it means x to the power of a quarter. So I think that just on the side, so that if they throw in something that again looks quite different as a normal, that is basically the same. So we'll handle that one now. So then the next one was this one. So that is exactly the same as x to the power of minus 2. And then the last one is x a half. And because that is also x, we can take it to the top. So we can write it as x minus 2. Okay. So let's see, what do we have here then. So that one stays the same with 4x, so we don't have any issues with that. It stays the same. The 4 minus 1 gives you 3, so at least that one we have correct. Then we need to now say, so that becomes now again, so it is a half minus 1, and remember we need to take that half to the front as well. So in there I need to now squeeze the half. What is also important, if you now look at the next one, so let's keep the minus there. We'll take that to the front, so it becomes minus 2. Got the x, and then it will be minus 2 minus 1. So in this instance, what we first need to do, let's simplify that. So before we now start taking everything, we need to simplify it. So a half plus minus 2 actually gives us 3 over 2. So let's just, how did we get that? So it's a half minus, so what is that in terms of a fraction? 4 over 2 is the same as 2, because I just want to make sure that I'm working with the same things. So 1 minus the 4 would have given me the minus 3 over 2. I think that again, so there's a lot of things in this nearly that one just need to make sure that one concentrates as you go through the process. That one we're still happy with, not going to change anything there. This becomes the plus a half. A half minus 1 is minus a half. Important here, a minus times a minus becomes a positive. And that's sometimes one forget as well when you work with it. So I think that for me is another important thing. Remember, a negative times a negative is a positive, so it is positive 2x minus 2 minus 1 gives you minus 3. Then on this side, we still haven't factorized that, so we still then need to take that to the front. So that becomes 3 over 2, and then still we have 3 over 2, and see how quickly I made a mistake again. That needed to be negative, so that actually needs to be negative. So let's just, I can use the eraser as well, but I think that one, again, how quickly one makes a mistake. So negative 3 minus 2, and you need to say minus 1. quickly just give me in the chat a thumbs up, or put on your mic and say something that I need to quickly redo or relook at. Otherwise, I'll quickly finish this one, and you tell me if we can go to the examples that were in the study guide as well. Okay, so I get a few thumbs up. So let's just quickly finish this one, and then we can look at a few that was in the study guide as well. Okay, so and this is, so when you look at options in the exam or even in assignments, they can write it in a few ways. So we've seen how that was written. So this one is basically can be written as that. It can be written as okay, so there's a few ways that one can write that one. So again, in the exam, just and I know they like to make it difficult for you to see if you understand all the ways that it can be written. I think that is important, that one can actually be written in two different ways. The same if we look at the x to the power of -3, it could have been written as this as well. So that's another way. Then the last one we still need to look at. So the 3/2 or the -3/2, that nearly stays the same. But let's look at this one. So as in what I did here, I always want to make sure that I work with the same things, that I don't get confused. So 1 is exactly the same as 2/2. So -3 minus 2 is -5. So we're actually working with x that is -5/2. Okay, so again, it is very important to know just how you write it and how you work it out. Let's quickly get just feedback, and then when we go into some of the next slides in the presentation that I prepared. Happy with this, or is there anything that I nearly need to show again, or can we, as we work through the examples, basically get more clarity on it? I don't have an issue if I need to just look at one of the things again. Otherwise we can just go through it as we go through the examples. Okay, so I'll save this. I'll go back to some of the examples. I'll share some of these wonderful drawings that I hope you can actually see. We still need to find out how we can share the whiteboard with everybody as well. I think it's maybe settings on my side that is preventing that. Okay, so let's quickly go back to sharing again. Stop sharing and let's share. Okay, so basically what we've nearly done now is to look at a few of these examples. So this was basically the normal power rule that we looked at now. So let me get to example like this. So let me quickly see if I can actually draw on this. That will be quite cool. Okay, so obviously we've got the answer there, but let's look at that and just from the things that we've now been discussing. So the x4, and let's do it here, becomes 4x 4 minus 1, because I don't think they really show there how it is done. So then we have the 2 that is normally there, and we will multiply that by 3. And what we then need to do is to say that x is 3 minus 1. Then the next one is for minus 5. What we need to do is multiply by 2. I'm going to try to squeeze in there. Assume that is a bracket, please. The bracket, and it is then 2 minus 1. Then with the 3x, remember if there is nothing, it actually means 1. So it's 1 minus 1. And what happens with the 100? Because there is no x, it just disappears, so it becomes 0. Okay, so whenever there's a constant, that basically will disappear and become a 0. So I think that's the other thing in the differentiation. If there is a constant, if you differentiate it, it will become 0. Okay, so with this one now we can say that is x3, so we're getting that. So 2 times 3 is 6. Three minus 1 is 2. So happy we have that. Remember there's a minus, so 5 times 2 is 10, but because of a minus, it's minus 10. We've got the x. It is 2 minus 1 gives you 1. So again, we have it there. And then 1 minus 1 is 0. So another rule to remember, x to the power of 0 is always 1. So plus 3 times 1, so that will become 3. So we have the 4x to the power of 3 plus 6x to the power of 2 minus 10x plus 3. So basically we got to the right answer. So with the, and let's just go to, so with the power rule, this is basically the first one that, yes, we will see now some more difficult ones as we go through it, but this is the basic one that I can ask you with a power rule, and that was nearly the one that I showed previously with a few of the things that I've put together. So power rule, in a sense, is the simpler of the problems that you will face in the exam, or as you would have seen in the study assignment. They won't tell you that we're gonna, you will see, they will just ask you differentiate the problem. They're not going to tell you differentiate by using the power rule. And I think that is important with all the differentiation rules or examples, is it is now nicely grouped into the areas that we work through. But in the exam, they're just going to say differentiate, and then you need to try to figure out what is the power rule, what is not. So as we go through some of the problems now, I will, in a sense, give you an idea of when to use what. Power rules one is very simple to identify when it is the power rule. You will see you will always have just the normal plus or minuses in between the terms. So you will not have the multiplication or anything like that between terms unless it is a multiplication like I'm showing now, where it is just a normal x times the x to the power, or x4 to the power of x3, because that you would have been able to first multiply it out to make x7, and then you can use the power rule again. So for the power rule, very basic, look at it in between the terms, it will be a plus or a minus. So let's go to the next one, and again you can see there's not a lot of space now quickly to work it out, but I will go through each one that we just get the essence what we need to do. So nearly the same that we did in the previous one. This one again, very, very straightforward. You add the 10, so we keep the 10. The 8 becomes in front of the x, and then we will need to say 8 minus 1, because we just take it the 1 away, and that becomes then 80x to the power of 7. So this is nearly the easiest one that we will see. I haven't had complaints that you can't see, so I assume I am sharing the right slides, and that you can follow on it. Okay, so this was the one that I also now showed previously. So if we need to, and not if, we need to rewrite it to make it easier. Otherwise, I would have, it becomes very difficult if you don't separate it, but you could have said, but I won't recommend this because you can easily make a mistake. But I could have said, let's forget about looking at it from what is above. Let's just work with, let me quickly erase that. So let's just work with what is below, and that is x squared, x to the power of 2. So if we would have just looked at it from that point of view, our normal way of looking at it would have said, okay, take 2 to the front, let's take do that, and our answer is 2x, and let's then just put the 1 back. And then you see you get a total different answer. So, and that is why you can't just work with what is under the basically division line and just say, oh, okay, let's work that out, and then, oh yes, it was divided, so let's put the 1 back, because you will get a different answer. So please, that is not the way of doing it. So let's go back to how we need to do it. So first, as they tell us, we need to transform that, and the way we transform it is to bring everything to the top. But if we bring everything to the top, it becomes that. Okay, then we can start our normal process. So we take that to the front, so it becomes minus 2. the x, and they explain it nicely where it's basically minus 2 minus 1. So we get the minus 2x to the power of minus 3. Okay, so that is nicely explained there as well. And then it can be in that form that they ask you to write it in the exam, or then you need to write that back in the original form as it was in the question. So it is basically the minus 2, or as they say, minus 2. Doesn't really matter where it is. So that is also something that you can look at in the exam. There is a few ways of writing this. Okay, so it can be that they put the minus with a 2. It can be even that they say minus x to the power of 3, or it can be that they put the minus as they do in this one. So they could have put the minus there, they could have put in the minus there. It doesn't really matter. Okay, so let's see. Must we do 3 and 4 as well, or can we go on to the next one? So just give me an indication if we need to maybe look at one of these. So I am following the chat, so tell me 3, 4, all good, happy to move on. Everybody else also happy? Okay, cool, we can go on. If there is anybody that says no, please shout. Can we do 4, please? Okay, let's look at 4. Yeah, I think that is also very important. So let's quickly look at 4. And I think what is important with 4 is these two that basically is below. So the x one is always the simpler one. So what will happen with x is, remember that x is always x1. So when we differentiate, we need to say minus 1. The minus 4, 1 over x. So again, how we're going to change that is we need to say the x minus 1. And then the same with the plus 8, 2 times x squared. That one will, where it is 2 over x squared, we will need to write that as 2x to the power of minus, wait, yes. Okay, so there you could have been, that is quite interesting how they've written it there. Okay, because now you also need to still remember to add the 8. Okay, so there one could have easily made the mistake to all forget the 2, or you've forgotten about the 8, but remember, and we haven't differentiated even, so that is how it should be before we differentiate, and then that will become 1 because it is x to the power of 0. With this one, the minus will become in front of it, so minus 1 minus 4 gives you a positive 4. The x minus 1, it will be minus 1 will give you the x minus 2. And here we already remember that 16. And let's just see, it was plus. So minus 2 times plus 16 is minus 32. And that will be to x to the power of then minus 3. And again, here you can see they could have given you that option in the exam, or they could have given you that option in the exam to basically work with. And both is right, and they can in the exam also say it was 1 plus that minus that one. So just remember it can be in different formats that they can put it in. And it is for you to recognize if that is the valid option. So just remember that they can use it they don't need to everything be in the simplest form as they would have wanted it. It can be in any of those combinations. Okay, so we're happy with this. Let's go on to the next one. Okay, so I think this is also becoming important now. Suddenly, I said to you in the previous slide, product rule is when we add two things together, but now suddenly we have in this one a division. So do we use one of the other rules? Don't we? For this one, it is still the sum, and I don't want to say simple x, it is one term. So if it is one term, we can break that up as 5x over x plus 2 over x like they did here. You couldn't, and that is very important. If it was something like that, that you would have needed to say then is 5x over x plus 1. I'm now trying to squeeze in plus 2 over x plus 1. And then that is definitely not the simple rule that we are working with currently. So I think that for me is important when you look at, because here we would have used in some of the more difficult ones where I think were quotient rule and things like that. So very important for me for this is still that you need to easily be able to split that. And then it is as simple as the previous ones that you work with. So happy that is nearly the same as for other ones. Yeah, basically, and I'm just quickly running through it that we can get to the other more difficult stuff. Again, just follow the same principle as we did with the previous one, and you will get to the same answers. Let's quickly see here if there's anything different. So again, not really anything different here than what we've done. For me, remember that is also how you can write it. So I just think there's the one that stands out here is the different ways of how to write it. Then it nearly follows the same principle. This one we quickly did in the previous one, but let's again, okay, I actually explain it very nicely here. But for me with this is if you get something that is different. So you can get that one and you need to know then what to do. But again, it is exactly the same principle that you follow as in the example below. So just because it's a 5, a 10, a 99 or whatever, it doesn't change the principle in how we do it. Okay. So let's see, and I'll save this as a file on my side as well, and then I'll share it to you again. So don't worry that some of these are maybe taken away. I'll share it again back to you. Okay, this one I think we need to quickly check, because here one can make a few mistakes. So what we have here, and yes, they've done it nicely there, but let's write it again as I would have liked to see it. So first, above the line is q to the power of a half. Below the line, it is q to the power of 2. Then, if we work with that, I always want everything to be at the top. So it is q half times q, oof, that was terrible, minus 2. And that will then give you q a half minus 2. And I think that is nearly what you need to realize here, minus 2. So that is q then a half plus 4 over 2, where it is then q 5 over 2. So that one is nearly done with that, and you can see we have a 5 over 2 there as well. So again, it all depends on what is the final answer that they give you in the exam, because both options could have been, according to them, the final option. So I think, again, really to understand the different ways that they can write it. The reason, and I think when we get how that was done, so remember we would have said that is 5 over 2. So if we taken that to the front, it would have been 5 over 2 times 4. So it is, let me just quickly see if I'm now making my sums correctly. Wait. Now I am confusing myself here as well, because I skipped a few steps. So remember when we did that, that is quite interesting. Let me just quickly see what I did now. So we needed to work with that. So you would have taken the 4. So it is 4 times 3 over the 2. And that is where they got the 6. Okay. So that is where they got the 6. So again, I now skip steps, but you need to do it step by step to actually get to a constant as well. So again, I think the process here is one of the simpler formats, but please, you need to nearly keep your head in when you're doing the calculations, especially when there's the negative involved, because it can quickly become that you make one small error somewhere, and then the whole answer is wrong. Okay, so that was nearly the power rule that we have done. Let's just quickly thumbs up. I know everybody wants to move on. Let's just get a group view if everybody is fine with where we are at the moment. Okay, cool. Seems like everybody is fine. So let's go on to the next one. So let's get starting to the more difficult ones. And I think when we start looking here, so the exponential and or let's just call it the exponential and log rules. Again here, and I still need to see. It depends on how the exam will look like. If you get it's going to be difficult. So I don't know if it's going to be open book and you can look at the definitions. I will also write for you a page with definitions that I'll share later on, so that at least we just have a view of what's the log rules, what's the power rule, what's the product rule, what's the quotient rule, what is all the rules, that you at least have all of that on one page. I'll do it with some of the previous chapters as well, when you needed to work out the consumer surplus and producer surplus and all those things. So I will share that with you, and hopefully you will get something like that in the exam as well. So let's quickly look at the exponential rule and what do they say. So if it is the normal e to the power of x and we need to differentiate it, it basically stays the same. Okay, so that's in the simplest form. So if it was e to the power of, okay, so let's get to the next one. So let's not that I'm confusing you. So let's just, in the simplest form, it actually stays the same. Okay, so then if you look at, if we start adding a constant in, so if it is e to the power of 3x, the only thing that happens here is that we do something with the 3. So then it becomes 3e to the power of 3x. Okay, so that is nearly the next step in recognizing if there is a constant. All that happens to that constant is the constant moves in front when you differentiate, but that term stays exactly the same when it is in the simpler format. Okay, so that is the first thing to recognize. So then what, again, if you look now at the next problem, or there is the problem, nothing prohibits them to, in their exam, to do this. And I'm now at the top of the screen. Nothing prohibits them to give you a question like that. So it doesn't need to be purely the product rule, or purely, it can be a combination of. But for this one, because it is still simple, the plus in between the two terms, you can deal with that as we did previously, and you can deal with this as we can show out of this one. So if you get something like that, you just break it up in the two things that you know how to do. But nothing, again, if you look at past papers, and I'll share a lot of that just before your exam time as well, is they like to combine with things. And that is, again, a way of them testing that you haven't just studied one component, but that you can nearly integrate the two. But you deal with it as two separate. So let's quickly look at this example, and then we can jump into some of the other more difficult rules into this as well. So in this example, it was actually straightforward. There was no constant before the x, so it actually stays the same. Nothing changes, write it exactly as it is. With this one, the 3 was the constant, so the 3 would have been going to the forward, so you will get the 5 times 3. The rest will stay exactly the same, so you will have your 10 e to the power of x that stayed the same, and the 5 times the 3 will give you the 15, the rest will stay the same. So in a sense, this is nearly the easier of the ones that if they give this to you, very simple to format. Then, so that was the first one that we needed to nearly know what to do with. That was the second one if we get a constant. The third one that we throw into the mix now is log or lin, or however they want to use it. And again, remember they can write that as that as well. So it's just that if, terrible writing there. But if they can in the exam say ln of x, or they can say log e of x. Again, they can use it interchangeably. So for me, it's important that just remember the both ways of writing it. And yes, for confusion, they can do this so that you just get so they can say in the exam differentiate that for me, please. And then suddenly you're like, oof, okay, but I know I know there was log E somewhere in the process. Why isn't it the same? So just remember that they can basically throw in both of them in the same question, and you handle it exactly the same. So out of differentiation rules, ln of x is 1 over x. Okay, so if it was 2 ln of x, it would have been 2 over x. Okay, so that would have just been on top. Okay, so I think, but on this, there's basically three rules to remember. Okay, so the next one is the chain rule, which I think that is where everybody wants to start getting to. So exponential log functions, again, it looks simple. There will be some of it in the paper. It will probably be combined with something else, and probably will be combined with some of the things that we will start looking at now. Okay, so the next one, I think just everybody fine that we go on? I think so. So let's move to the next one, the chain rule. And again, if we look at the chain rule, this is nearly what you need to remember. So if we have two functions, basically what it is telling me is, if I look at the one function, I will take the function, I'll look at the derivative of another function, I'll multiply it again, and I'll look at the derivative of the other function. So that is basically what that and that means. So let's rather, instead of going into the detail of that, let's go to one of the examples, unless you quickly want me to go through the chain rule and what it does. But I nearly think it's easier to look at an example for this to puzzle it out. Happy with that? Again, I will give this to you on a list of rules. You don't need to prove a rule. You don't need to. You just need to know when you see it in the exam that this is the rule that I'm going to use, and then what you need to do with it. Again, in what the exam will be like in this term, I don't have an idea how they're going to structure it. So if it is nearly in an open book environment, still what I would do is, and that's maybe another tip, and when we get closer to the exam and we know exactly what it is, if it's an open book and it's an online exam, please write all your rules and all your functions on a page. Don't think that now suddenly, because it's open book, you can go and look for the function in the book, please. So that's just another tip from my side, because I've done a few of the open books, and you think you've got all your equipment with you, you'll find it, but please write as many equations down that you exactly know which one to use when, and then it actually becomes nice to use it as a tool. Okay, so let's look at what we need to do. So let's see how many examples are here, and see there. I'm just quickly skipping through a few, but again, now this is what I nearly wanted to show. So the exponential one looked very easy, but then they start combining it with another one, and then it becomes much more difficult. So let's first look at the more simpler one. Okay, everybody happy? Everybody got another cup of coffee? So let's go on. Okay, so basically, if we look at a problem like this, you need to nearly say, well, as they say, we denote the one function and the other one becomes that, but basically what we are going to do here is you will do something with the middle or the first term, and you'll see that is what you do there. So basically you will say, well, let's call that u. And what we are going to do with u is, for the first thing we're doing is we are differentiating u. So then that's the easy one that we've learned in the previous rules. 2x plus 3 to differentiate that. Simple, the answer is 2. Okay, but now what happens with that one? Okay, so with that, we basically, because we defined that as u, it becomes u to the power of 5. Now we need to differentiate that. So don't start including the x plus 3 yet. We are differentiating u to the power of 5. So u to the power of 5, again, from the previous work, very simple differentiation. So it's not anything difficult. It's u to the power of 4. So it was the 5 minus 1 have given us the 4. Okay, so at the moment, very simple, 5u to the power of 4 is the other one. So if we would have written that down, at the moment it is 2 times 5 u4, which in a sense we can manage with. Remember, we replaced the x to the x or 2x plus 3 with u. So here, all that we do is we replace it. So we just replace it with what it was. So we replaced here and we write it over as that. And then the 2 times the 5 would have given you the 10. So then in the simpler form, that is your answer. Okay, so basically what we are doing here is we using our previous things that we've learned, and we use it in a different format, but in a sense always try to keep it as simple as possible. So basically what we did here is we replaced that. So if you look at how they set here, basically what you are doing is you differentiating the u and you multiply it with a differentiation of the other the u to the power of 5. So let me, sorry, that is, so you differentiated it, or you multiplied it with a differentiation of the u to the power of 5. But it's nearly, and that's why if you look at that, and I think that was what a lot of confusion caused, is what does that actually mean and what do you actually do with it. But looking at the example, it is actually very easy if you do it step by step, to get to the answer. So quickly on this point, we will go through some of the other examples as well, because it is not just as simple as this. But are you guys happy with what we've done up until this stage? So let's just, okay, we've got a few thumbs up. Okay, cool. So I'll explain the other ones as well. So just for the guys that have been joining in between the session, please just note your, if you haven't, note your student number on the chat, please. Then the other one is also, we have a WhatsApp group running as well. If you want to join the WhatsApp group, give me a WhatsApp. It is somewhere on the chat. I gave my number, but it's 083-790-8387, and somebody else can share that number again as well. So let's continue. Okay, so now it becomes a bit more difficult, and I think that is where we need to see what else to do. So let's quickly, out of the rules again, and every time I'm nearly gonna say let's go back to the rules, because that is how we're gonna do it. But let's look at this one. So again, if it was the simple exponential, simple log, then it would have been easy. But now let's follow the principle that they are doing. So let's go and say u is equal to 4x plus 5. And again, depending on how your exam is going to look like, if if you have rough paper at home, or if you do it in the exam and it's at home, please, for yourself, make this that you don't skip steps, because when you skip a step, and it's nearly like the previous one that I did, if you skip a step, then it becomes confusing. So rather with this, do it as you can. There was a few guys on the WhatsApp group that also shared um, the calculator that can be used. So again, if a calculator can do these stuff, please use the calculator. And again, if you're not on a WhatsApp group, you'll join, and there's some of the guys that will share again some of the pics of a calculator that can do some of these things. So please, because as you'll see, this is not an easy process as we go through the problems. So please, where you can use calculator, do it. Okay, so basically the first thing is we say, okay, we're going to replace u over 4x plus 5 by u. So let's go to the next step. So if we go to the next step, we basically have EU, and that we're going to differentiate, and then we're going to differentiate the x plus 5. So that is the two ones that we're going to differentiate. That, from the previous section, we know stays exactly the same. So for now, let's write it down as it is. Then if we look at this, if we differentiate 4x plus 5, again, constant, so that will fall away. The 4x becomes 4. So what we have here is we've got e to the power of u. Sorry, that now nearly looks like the 4, so let's not times 4. And then, as simple as is, we need to replace the u by what we said u was. So e 4x plus 5. Okay. And that is the answer that we get there. But I think what is important here is that, again, when we look at, say, it's a combination of a previous work. And that's why I nearly didn't want to go too quickly over some of the previous work, because it nearly builds up every time. And remember that this then it's the exponential one. So we need to remember what do we do with the exponential one, and then it becomes intriguing when it is adding another dimension to it. So it is basically looking at two functions, because what we sometimes want to do is, and that I've made a few times that mistake as well, is the rule for that one says from a previous one is that, and that stays the same. So it's nearly like when you first look at this, and it's like, okay, e times there's your e to the power of. So it nearly, for me, your first instinct normally is it needs to stay that way. And if it was just the x, it would have, if it was just for 4x. But just by that simple extra adding of a plus 5, now that becomes a term that you now need to treat differently. Okay. Okay, let's just quickly, so, and that's what I think, so how the 4x became 4 again, and that's way back from the first thing that we did, the 4x, so let's just quickly rub that out. So 4x, if we differentiate the 4x, remember there's always that 1. When we differentiate, we need to say minus 1. So the 4x will be 4x to the power of 0. X to the power of 0 is equal to 1. So it is basically 4 times 1. So that is how we got to that 4x again being the 4. Cool. Okay. And that's why it's good that you ask the question, because it is nearly, again, don't go to the most difficult differentiation, and then try to work with it, because it does build up. Okay, now let's look at the question 3, because I think this is some difficult stuff. So when we look at ln, and from a previous nearly slide, what we said is ln, if it was ln of x, it would have been easy. Ln of x would have been, but if we differentiate it, it will be 1 over x. So my first instinct would have been, well, ln, here's ln of a term. I would have said it's 1 over, that would have been my first instinct to do, is to nearly do it that way. And trust me, in the exam, that will be the answer for you as well. In this one, it's very interesting, because nearly, in a sense, that is part of the answer. So I don't want to say for shortcuts, but if you needed a shortcut in the exam, it's basically, that would have been the first thing that you do, and you will differentiate the thing that is with the x. So in a sense, that is a shortcut, but let's do it the right way. So the right way to do this is, okay, let's again define what u will be, and please, in here they use it you can define whatever value you want. It is not, there's no right or wrong. You could have said this is z, or you could have said it is p. It doesn't really matter. So let's define u again, and u will be the 5x plus 1, and always try to make it that you work with whatever that term is to nearly make that the subject of, so make that equal to u, and see how easy one can make a mistake. 5x minus 1. Okay, so let's make that u. So with the rules that we have, very simple. The first one is, again, that we will differentiate that. So the ln of u multiply, so let's just make it that, so we're going to differentiate ln of u. So I'm not writing all the differentiation code, and then we're going to multiply that by the differentiation of 5x minus 1. Okay, so we're differentiating that, and we're differentiating that. So the ln of u is 1 over u, as we've seen in the previous example of the rule. The differentiation of 5x minus 1, again, nearly how we did it in that process. And let's work from there. So 5x minus 1 becomes 5. That will fall away. So basically, we have 1 over u times 5. Remember, again, then whatever is for u, we need to, so you could have written it as 5 times 1 over 5x minus 1, or you could have said 5 over 5x minus 1. Okay, again, terrible handwriting on the screens, but basically that is the two ways that you can write it, and it can be, again, in the exam, doesn't need to matter which way they give it as an answer. That is the way. So basically, here we've done one that is a simple term to the power of something else. We defined what u is. We basically differentiate the one, we differentiate the other one, we combine it in a multiplication, and we get the answer. Here, exactly the same, but a bit different because we are using the log rule, so it just becomes a slightly different what we do. So let's look at another one, and I think this is probably the last one before we go into the product rule. So quickly, when we look at this, always, and I think that now we've nearly come to into this routine. Let's define. So in here, don't make the mistake to say u is equal to 1 over x plus 7, because you see that as the term, because that just becomes then a nightmare to work with it. So always try to keep it as simple as possible. So again, u equal to x plus 7. So that will be our u. Then let's differentiate. So we would differentiate the u. So if we differentiate the u, it is u minus 1, and we will multiply that by the differentiation of x plus 7. And so this is very interesting what we are seeing here. So let's just quickly so that is, again, how quickly one makes a mistake. Okay, so it is 1 over u that we need to differentiate. So I just wanted to differentiate u, but it is 1 over u that you need to differentiate. And again, very quickly one can make that mistake. So I would have written it, if I needed to do it in the exam, so that I don't make that mistake, I would have originally said, this is what I need to work with. Because then, otherwise you write u and you work with u and you actually forget that it was 1 over u. So I would have written it in this nearly directly into this form, but otherwise you could have written it into the 1 over u. So I think very easy here to make that mistake in not doing the fraction up front. So we differentiate that. So if we differentiate that, again, it is from the previous section nearly -1 we have, times, or not times, and we take off -1. So that would become minus u to the power of -2. Again, that one can be rewritten as minus u over 2. Okay, then we need to differentiate what was in that term. Nearly like the previous one, we differentiate a constant, falls away, the x was 1, so 1 minus 1 is, so that for me is, so you get to x, 1 minus 1 is equal to 1, so it is actually, we just multiply by 1, and then we need to replace that still with what it originally was. So now the question is, sorry, yeah, I made a mistake. It's not going to be over 2, so let's not, I nearly made a mistake, so please, when I do that, shout out, I'm writing it wrong. So again, I now quickly wanted to do one thing finished and then look at the other one. Please, in the exam, don't make that mistake that I now did, that you first want to work with the one term and then the second term, because it nearly wants to finish the thought that you had. So please do it simultaneously. So we've got the one, we multiply it with the other one. So at the moment we have minus u to the power of -2. Okay, so we now need to replace the u still. So it is, again, there's 2 ways that one can do that. So let's just do the 2 ways, and I'll write it here. So the one way is, as I did it there, you can say it's minus, let's use the brackets before we again write something that it's not. So x plus 7 to the power of -2. So we basically just replaced the u into that. And the other way of doing it is to say, well, what we do is we want it as nearly a positive fraction. So it is 1 over the u square. So and it becomes that. And then again, the minus can be there, minus can be there, or the minus can be in front. It doesn't matter where the minus sit in the end of a question. Okay, let's quickly thumbs up or down or go on. Happy up until this point? I need to go back to anything up until now, just shout on the chat as well. I hope everybody is still there. Okay, cool. So up until now, I think it's, when you originally looked at this, it is extremely difficult if you just come in totally blind into differentiation, and it's like you nearly need to find a way for yourself to get to this. So I think it's more the step-by-step way of doing it. So let's go into the next one, which again, the product rule. So let's, instead of learning that and writing it down, yes, you can write it down. I'll give you it on a paper again, but it is nearly what do you do with it? And basically, in a layman's term, if we now divide those two, so with a product rule, you will have two functions, even more, that you work with. So in the product rule, you have two functions that you work with. So basically what you do is, if you look at those, you will differentiate the first one and you will multiply it by the second one. Then you will say, I will add it to, now you keep the second one, the first one as is, and you multiply it by the differentiation of a second one. So basically, let's just rephrase that as they are showing here. So when you have your product rule, you will basically say, differentiate that. So you can see I differentiate my first term and I multiply it by the second one. Then I add my first one, which I multiply with a differentiation of a second one. So let's, before we get into, okay, now let's, I think there is a nice, no, so let's, oh, that is even a more difficult one. So let's go into, I don't want to explain it with that. Let's go into a problem like that. So in the back of the mind, always remember your first term, you differentiate that, you multiply by the second one, plus then differentiate the second term, multiply by the first one, if I now have said it correct again. So here we have the two terms. So EX is my first term, and X plus that is my second term. So just remember, that's your first term, that's your second term. So what do? We take the first term and we multiply it by the differentiation of a second one. So the second term, we had that. If we differentiate that, it becomes 2x to the power of 1, because we said 2 minus 1, constant falls away. So out of my first one that I did was, I said, I take that, I multiply it by the differentiation. Then I need to do the second part of it as well. So the second part of it is, okay, so let's just see, there was the first part, so they just did it the other way around. So the next part is, I differentiate that. So what do we know of our rules? If I differentiate that, it stays like that. So again, it's nearly all the previous rules that we had, we're just using again. So differentiating that, multiply by that one. Oh, sorry for that bracket. So that is basically then what we did with another one, and here it was. And that could have been your final answer, but because you have the EX there as your common factor, you can take the EX out, and then you just write the rest of, there's an x squared left, there's a plus 5 left, and there's a plus 2x left. And they could have done it that it needs to be in order of, so they could have written it down as that as well. So in this one, okay, so just quickly why the EX stays the same. It is from a previous log rules. Where was it? From the exponential and log function. So that is purely, again, why I said we're nearly building up from the beginning of a chapter to the end, and every time you nearly need to remember to what the previous rules was. So EX differentiated stays exactly the same. That's the rule. You don't need to worry why it's like that. Luckily, we don't need to go into proving anything like that. So it just stays the same. Okay, so this was, again, nearly doing one of the more difficult ones first, because you need to remember the rules. But again, very simple in a sense that you take the first term, you multiply it by the differentiation of the second term, plus the second term multiplied by the differentiation of the first term. So let's look at another question. So here we have, again, two terms. It is in brackets, so we can say that is one term and that is another one. Don't make it more difficult for you to now say, oh, but there is now 3 terms within there, there's 2 within there. Not at all. That's with one term, that's the second term. And now that is nearly going back to the first thing we nearly did this morning, is when we start differentiating, we need to differentiate those. Okay, so the rule for this differentiation, again, let's take the first one as is. So I'm not gonna, and we differentiate that, or we multiply it with a differentiation of a second one. Okay, the differentiation of 3x plus 2 is actually just 3, because, again, 3x plus 2, from all the things that we've done this morning, the 2 disappear, the 3x becomes 3x1 minus 1, so the x doesn't disappear. So the first one that we've done, we've kept term 1, we multiplied it by the differentiation of term 2. Then what the rule says, okay, we need to add the next thing that we need to do. So the next thing is we need to differentiate that. Okay, so now, again, I'm going to do it quickly, simple way, as how I would have done it in the exam. So to differentiate x to the power of 2, that is 2x. To differentiate 2x, that becomes 2. Differentiate the constant, it falls away. And I multiply that by my second term, which is 3x plus 2. 3x plus 2. So now we sit with a function that is 3x to the power of 2 plus 2x plus 1 plus 2x plus 2, 3x plus, sorry for that. And what you'll notice is I'm doing it a bit differently to what they are doing, but it's easier for me to nearly start with a 1, differentiate with the second one, plus differentiating the second one plus the next one. It's just that I don't, for me it's easier, because then I know I'm I'm doing it in steps that I can easily remember. Both ways are fine to do it. So it is to find a way for you to actually what makes it easiest for you to do. As long as you do the same things, you'll get to the same answer. And these two terms now, unfortunately, we still need to simplify, as you would see. So 3 times 2x is 3 times x to the power of 2. 3 times 2x is 6x. Just imagine that's a 6, please. Plus 3. And that one, we also now have the algebra of nearly the first chapters. 2x times 3x is 6x to the power of 2. 2x times 2 is plus 4x. 2 times the 3x is plus 6x. 2 times 2 is plus 4. So now we've got that we still need to simplify that. So we take all the x to the power of 2. So 3 plus 6 is 9 to the power of 2. Let's look at where all the x's are. And hopefully we didn't make a mistake. 6, 4 is 10, 16 x. And then all the constants, 3 plus 4 is the 7. And then we get to that answer. So again, just following the principle, because I think when one gets these questions, it looks daunting, because it's huge terms and one is nearly, what do we do with it? But nearly step by step. I think we've only got about 9 minutes left, but I think we've actually covered a lot in this session, and we will next Saturday. I will continue where I left off here. I will not now suddenly jump to the next chapter, because I think it needs to build up, and then as you go through this chapter now again, I think what's important about this is step by step. Don't try to skip steps. If you can use a calculator, it's something different. But if you want to calculate it yourself, please step by step, and don't skip the steps. So let's quickly check some of the other ones. So let's look at this one. I think that one you can also look yourself and see how to do it. So let's look at nearly question 4. Yeah, rather and then we'll can do the quotation rule. So let me quickly explain the quotation rule, and then I'll go back to function 4, so that we can just, because quotation rule, and then we're done with so or the quotient rule, sorry. So what we need to do with this one, nearly the similar kind of approach. So what's important here is you work with it, and so you work with two terms that you are dividing by one another. And that is how it will always be for the quotient rule. It is when you have two functions and you divide it by one another. Then it again, like the previous one, is nearly a very, I don't want to say simple, but it's again a process that you need to follow. So here the process is differentiate that times what is under the division minus differentiate that times that. So it's nearly to say differentiate what is on top times the one that's below minus differentiate that's on the bottom times the one that's on the top. And then important that when that function that you have at the top, that you divide it by the one that was on the bottom to the power of 2. So this one again also is nearly step by step that we need to work that out. So let's do one of them, and then we will probably be out of time, but then we nearly covered everything, and one can then say differentiation for chapter 5 we're cool with, but please then we can chat on the WhatsApp group about this as well. Okay, so let's quickly do this, and then we finish for the day. So the simple form of how we're going to do it is what's on top, we need to differentiate. So differentiate what is on top. So that is my rule. So if we differentiate that, it becomes 2x plus 2. And so let me get some much more space. So 2x plus 2, and that is from the things that did very early this morning. And we multiply it with what is at the bottom. So stays the same, what is at the bottom, we don't change anything. Then we say, okay, so the first one we did say we differentiate the first term times what is at the bottom. So now it is what is at the top and we differentiate that or multiply that with what we need to differentiate at the bottom. At the bottom was 3x plus 2. If we differentiate 3x plus 2, it is 3. And then the rule says whatever is at the bottom, we need to do that to the power of 2. So the rule is differentiate the first one times what's at the bottom minus what's at the top times differentiation at the bottom, and we divide by whatever is at the bottom of that equation to the power of 2. So yes, you could have now said put it in the v and the u's and whatever, but this for me is nearly an easier way to say, let's start at the beginning, differentiate times what's at the bottom minus what's at the top, differentiate at the bottom, and we need to divide by. So there you can see we did that, we got that, we had the negative, we've got that, and we've got that. So we've got that process set out without it nearly becoming too daunting that what is happening in this. And yes, unfortunately, with an equation like this, there will be things that you now need to multiply out to get to the next level. And then also, I think what's important with this, let your answer guide you into what the level of simplification needs to be. If you see at the bottom nearly that you have that, then don't in that instance now want to simplify it and multiply it out. So nearly take the guidance of what is in your answer to see how far you need to simplify. Sure. Okay. That has been a lot for the day. I hope really that this did add value and that it is better understanding the chapter 5 now. Chapter 6, I will next week handle it the same way. If you're comfortable with that it's nearly going through it to explain, to just show you what is in it for you to understand, because I think at the beginning of chapter 5, it's like, phew, we've got all of this rule. How do we remember the rules? But it is doing it step by step. Start at the easiest one, go through it, get to the more difficult one. When you get to the more difficult one, it's actually not that difficult. It's just need to remember the steps within it. But hopefully you get the steps nearly in the exam, how the formulas will look, but I will also write it for you in an easier way that you can understand it and have it. Okay, cool. So please give me feedback. I think there is somewhere on the Teams page, there is nearly like a link on giving feedback as well. Yeah, so please let the recording will be available. I'm gonna save this with all the scribblings on and share it also back into the environment. I will make a PDF copy of this and share it on a WhatsApp group as well. But yeah, I think hopefully this did help. Give me feedback in the WhatsApp group. I'll add you to a WhatsApp group. If you're not there, send me a WhatsApp. And yeah, let's continue next Saturday. We do exactly nearly the same with the next chapter, and we continue with it until till we've done with this subject. Okay, thanks guys. It's been nice on this Saturday morning to assist you, and please, yeah. I will see you or speak to you again next week in this form, but please, we do on the WhatsApp group, we do communicate quite quite a lot. So, and I don't mind it, and I think also the Teams pages will be open for you to chat as well and leave messages. But yes, thank you very much. Enjoy the rest of your Saturday and long weekend, even though it is at home. And yes, and keep studying. I'm also now going to probably do some studying on this side. Cheers, everyone, and have a great Saturday further.
Thanks, John.
Cool.